In this video, we are going to find a definite integral in using also the u substitution. So we have the definite integral because we have these limits, the lower and upper limits. But how do we handle that? The first thing is to find an antiderivative. So we're going to forget about the limits 0 and 2 in this case. So let's just find an antiderivative of x times 4 minus x squared. So forget the limits. Now we can rewrite this as x times 4 minus x squared to the power of 1/2 dx. And in this case, our u is the inside function. So u here is the inside function here, 4 minus x squared, 4 minus x squared, and right away we compute du. Du is negative 2x dx, or if we divide both sides by negative 2, we have negative 1/2 du equals x dx. So this means now that the integral x 4 minus x squared to the power of 1/2 dx, which can be rewritten as 4 minus x squared to the 1/2 times x dx. So I just move the x next to the dx. Now is equal to the integral of u, because this expression here is u. So we have u to which power? To the power of 1/2. And then x dx is 1/2, negative 1/2 du. Remember, it's times, so I'm going to write the parentheses times negative 1/2 du. It's a good habit to write parentheses when you have a negative sign next to du. So, which is the same as, I'm going to write the constant negative 1/2 to the front. I move it to the front, u to the 1/2, and then du. Now this is a pretty easy antiderivative to compute, negative 1/2, and then times u to the 3/2 over 3/2, and then normally we should have plus c. The reason why I say normally, because the original integral here is a definite integral. That means we have lower and upper bound. So we're going to discard the c. So whenever we have a definite integral, we don't need to deal with the constant of integration. It's only when we have an indefinite integral that we need to worry about it. So this becomes, after simplification, we get negative, should write it in white, negative 1/3 u to the 3/2, which is the same as negative 1/3. And then what's u? U is 4 minus x squared. So 4 minus x squared to the 3/2. Now, once I have this antiderivative, I can bring the lower and upper bound. So now I have from 0 to 2. Okay, so let me just write it somewhere else so that we have more room. So we get negative 1/3 4 minus x squared to the power of 3/2, and then we had the limit of integrations 0 to 2. And you know, when you have this, the first thing is to write giant set of parentheses separated by a negative sign. So in the first set of parentheses, you plug in the upper limit. So negative 1/3 times 4 minus 2 squared to the power of 3/2. And the second set of parentheses, you plug in the lower limit, 4 minus 0 squared to the power of 3/2. So when you compute this, you should get 1/8 at the end of the day. So that's the final answer. Remember, when we have a definite integral at the end of the day, we must have a number, not a function. So we have 1/8. Now for practice, I'm going to assign some problems to make sure that you have mastered the concept. So problem, find this definite integral. The first one is the integral from 0 to 2 of x minus 1 to the power of 25 dx. And the second one is the integral from 1 to 8 of 1 over 3x plus 1 dx, which also sometimes we can rewrite this as the integral from 1 to 8 of dx over 3x plus 1 is exactly the same thing. So just by looking at these integrals, you can tell the u substitution. So as a hint here, u is the inside function, and as a hint here, u is the denominator.